Hi everyone, my name is Racquel Fygenson. I'm a fourth-year PhD student at Northeastern University. Today I'll be presenting research by myself and Steve Franconeri from Northwestern and Enrico Bertini from Northeastern. The research that I'm going to be talking about today is in regards to how the arrangement of marks impacts afforded messages. In this work, we investigate 4 different arrangements: ordering, partitioning, spacing, and coloring within bar charts, and I'll walk you through that in a bit more depth. So I'll start the presentation by explaining exactly what this title of our work means. I'll go on by describing the new methodology we use in this paper. Then I'll explain the 4 example experiments and their results. And finally, I'll go over some of the future work and next steps that we're planning on taking. So to start with, when we discuss the arrangement of marks, these marks are any visual objects that comprise a visualization. So that includes bars in a bar chart, dots in a scatter plot, lines in a line chart, very straightforward. And the arrangement of these marks are any manipulations that does not change the information that they encode. So, for example, with a bar chart, we could realign or reorient the bars, we could sort them in a different order, we could space them further apart, and this type of arrangement is not exclusive to bars, for example, but can really apply to any other visualizations as well: Sankey diagrams, pie charts, you name it. So the second part of this title, the afforded messages part, is a bit more complicated. The term affordance first started in psychology in the 70s, and it was quickly popularized by Don Norman and later adapted and has become a mainstay in human-computer interaction. Within HCI, the term affordance means suggested motor actions communicated by an object's design. Now, it's important to note that these actions are not explicitly physical, but that's how they tend to be characterized within interaction design. So we go ahead and we adapt this term affordance to visualization, particularly to non-interactive visualizations. In doing so, we replace the term motor action with a non-interactive visual task. So we're interested in how suggested visual tasks are communicated by the visualization's design. So why is this interesting? Well, typically within the visualization community and viz education, the hierarchy of effectiveness is the go-to method for understanding what makes a visualization effective and informing design decisions. So right now this reigns supreme, but sometimes it's not always effective in helping us understand the nuances between different visualization design decisions. An example of this I'll show you on the next slide. This bar chart and this bar chart, which has all the same information just in a slightly different order, don't necessarily communicate the same things. These both use the same encoding channels from our hierarchy of effectiveness, but we might find that this same data affords different visual tasks. Take a second to look at these 2 bars and see what different tasks you tend to do when you're presented with the data and no other information. You might have, for example, on this left-hand bar chart, noticed a decreasing trend, and in the right hand, notice this outlier in blue under Hall. So these 2 tasks, again, very different despite the data being the same and encoded via the same channels. In practice, it's a lot easier to understand these tasks through proxy messages. So we might create a proxy message that says, for example, the COVID cases are decreasing, as a way to verbalize the visual task of noticing a trend. A proxy message for noticing the outlier might be Hall had the largest number of cases. So this is what we mean in our title when we discuss afforded messages. By now, hopefully you can understand how afforded messages might be a very important part of visualization. So you might be asking, haven't people researched this before? And the answer is yes, they definitely have. Starting back in the 90s, we have some very influential papers from Zaks and Tversky, from Shaw et al. That investigate the affordance differences between bars and lines. And as recently as last year at Viz, we have some interesting papers looking into affordances as well. But the majority of this work tends to be exploratory in its methodology, very open-ended, and it requires qualitative coding. That's all well and good, but we present a different methodology. Our work, on the other hand, is confirmatory. It's quantitative in nature, and therefore it's very easily reproducible, reviewable, and adaptable. Now, we don't mean to posit that our work should replace the previous work. These two go hand in hand, they're very complementary. For example, this previous work is very good at generating new hypotheses of visualization affordances. That's in part due to its exploratory nature. These hypotheses can then be fed into our methodology, which can confirm them with higher statistical power and using a lot less resources than previous methods. Let me explain to you how our methodology works. So first, we have to feed it some hypotheses of visual arrangements and afforded messages. And again, these might come from the exploratory channels that I just explained in the previous slide. Next, we present one of these messages along with all the visual arrangements that we have hypotheses about in a randomized order. Then we replace a word within the message to make it into a very simple fill-in-the-blank. In doing so, it's important that we make sure that all the charts can be used to answer this question correctly. Then we ask the participants to fill in the blank. This serves as both an attention check and as a way to actually make sure that they do the visual task. Without this, we have no way of knowing if a participant has completed the visual task because, again, all of the visual arrangements that we present to them encode the same information. Next, we ask a participant to select the chart that they think makes the statement the most obvious to them. We use the term obvious as a way to operationalize affordances because an affordance is not a very common term, and so we want to use a term that is familiar to a general audience. Finally, we look at the proportion of respondents who report each visualization makes the message the most obvious. And if we see that there is a significantly higher proportion of respondents that reports a specific visualization makes the message more obvious, we conclude that there is an affordance by that visualization for that message. So we ran 4 experiments, both as proof of concepts for this methodology and also to begin to explore the space of visualization affordances. First, we looked at the ordering of bars. So all these bars, again, are the same and they're just ordered differently. Then we look at partitioning. So we look at stacked versus side-by-side bars that describe part-to-whole relationships. Next, we looked at spacing. So we have regular spacing and then irregular spacing to communicate groups. And then we looked at spacing to communicate groups versus coloring to communicate those same groups. One of the most interesting things about these 4 experiments is that even though they might seem very obvious, many of them, like spacing versus coloring, have never been investigated from the lens of affordances. Also, unlike much of past affordance work that focuses on comparing 2 different chart types, like bar charts to line charts, these 4 experiments focus on breaking down visualizations into the elements that comprise them. So we're really looking at small specific design decisions because we want to increase the granularity of our understanding of visualization affordances and hopefully lead to generalizable results in the future. We tested a wide range of messages, including those about ranking, those about grouping, those about proportions, and about part versus whole relationships. And we also tested some messages that were simply method checks. It's important that we get a signal from each stimulus that we test so we can make sure that participants aren't reporting one chart over and over again simply because they like it more. To combat this familiarity or preference bias, we crafted a couple messages that were designed to make sure that participants would choose a specific chart. So, for example, in this test on ordering, a lot of our messages have to do with ranking, and therefore we hypothesized would result in strong affordances from charts C and D, which are ordered. So we crafted this message at the bottom of the slide here that grouped the bars alphabetically in the hopes that this message would be afforded the most by chart A and participants would report it as such. And they did. We were able to get a strong signal that was not for chart C or D, so we were satisfied that the signals for chart C or D were not simply due to a familiarity bias. Another version of a method check that we ran were rephrasing. So we wanted to make sure that the word choice or the sentence structure that we used was not impacting the results of our experiments. and we found that they didn't. There was no significant difference in the signals we found. All of the experiments we ran had a sample size of greater than or equal to 128 participants. If a participant's answer to the fill-in-the-blank was incorrect, we threw out their answer to the obviousness question as well. And if 30% or more of the fill-in-the-blanks were incorrect, we deemed that they failed the attention check and we excluded them completely. The experimental design was within subjects, so all participants saw all charts and all messages within their single experiment. And we conducted only a visual analysis of confidence intervals, which I'll walk you through. So we avoided p-values and other forms of null hypothesis significance testing. We present 9 key takeaways in our paper, but I'll just walk you through some ones here. Some are pretty expected. So for example, we find that spacing affords grouping. Take these 4 charts. Each column shows a different ordering, and the top chart has uniform spacing while the bottom chart has irregular spacing. When we look at messages that group M and F together, we find that charts that space these 2 bars close together and farther apart from all other bars most afford this message. And that makes a lot of sense. That's pretty on par with our community's understanding of how spacing works. Just so you get a chance to see the strength of signal that we're working with, this is the figure of our results, and each of these bars shows the 95% confidence interval for the proportion of respondents who reported that that visualization makes the message the most obvious. So if we look at this bottom row and this blue confidence interval, you can see it's a lot further to the right, so there's a much higher proportion of respondents who said that chart D, which is the chart circled in red above, made this message the most obvious. We also tested this same visual task with other proxy messages, so these are 2 other examples, and as you can see by the circled green confidence intervals, we saw the same very strong visual signal. At the same time, we found that spacing does not afford global ranking. So the top 2 charts, those that are regularly spaced, correlate with these pink and orange confidence intervals in the top 2 rows, and we can see that both of them are significantly further to the right than the bottom 2 rows, which show the spaced conditions confidence intervals. In terms of our ordering experiment, we found that for charts that are sorted in descending order from left to right, they make messages about the largest number of items and the second and third largest number of items the most obvious. And we actually find the strength of the signal increases as we move into more nuanced messages. So as you can see, this green confidence interval in the 3rd row continues to move further to the right as we start talking about second largest number of items and third largest number of items. We see a similar trend when looking at ascending bars and messages about the smallest number of items. Again, this blue confidence interval, which now correlates with the ascending bar condition, moves further to the right as we start talking about second smallest and third smallest number of items. And just so you can get a comparison of these 2 trends, here they are side by side. For our part-to-whole experiment, we found that stacking affords wholes. For the strength of the signal, you can see this green confidence interval in the 3rd row. It's almost all the way over to the right, which means that almost 100% of participants reported this affordance. On the other hand, we find that arranging bars side by side affords part-wise comparison, and here you can see the strength of that signal in this orange confidence interval in the 2nd row, also very far to the right. Lastly, we compared grouping via color and grouping via space, and here we find that coloring affords global ranking more than spacing. So these top 2 conditions, which correlate with these pink and orange bars in the results figure, afford messages about the largest number and smallest number of items overall. And we can see that the distance between these pink and orange bars and the green and blue bars in the bottom 2 rows is less pronounced than in other experiments. So this means that the affordance that we're testing is perhaps a bit weaker than the others we've found, but it appears to be still visually significant. We also find that coloring affords 2 groups of 3 bars. So when it comes to messages about A, E, and F, for example, condition A affords these messages significantly more than all other conditions. At the same time, however, the signal goes away when looking at 3 groups of 2 bars. So messages about M and F, for example, or A and J, are afforded roughly equally by color grouping, and spatial grouping. Here you can see that signal, or lack thereof, between the orange confidence intervals in the second row, which show the color condition, and the blue confidence intervals in the fourth row, which show the spacing condition. You can find the rest of our results in our full paper, and this is just the tip of the iceberg. We tested 4 very specific arrangements, but there's plenty more room for this methodology to continue to help us understand the wide space of visualization affordances. So in future work, we hope to continue experimenting. We want to use this methodology to investigate other affordances, message types, other visual arrangements. And the thing that we're most excited about is how easy it is to use this method, which we believe lowers the barrier to a lot of this type of research. Hand in hand with that, we're making a series of templates that make it very easy to reproduce work, as well as adapt this method to new experiments. We believe that this method makes confirmatory affordance research really straightforward and therefore really accessible to other researchers at a graduate level, but also perhaps to undergraduate or even high school labs who hope to replicate some of these results and can make use of templates to do so. Lastly, we are building out a database for recording and accessing past results. We also anticipate that this infrastructure will allow for reviewing and discussing visualization affordance work, as well as proposing new hypotheses and comparing research. We really want to centralize visualization affordance findings, create a community, and build out the infrastructure that's necessary to take this work from being simply approachable to also having long-standing impact. Thank you so much for listening. I'm super excited about this work, and I would love to hear if you have any questions, concerns, or comments about it. You can always reach out to me at this email address in the lower left-hand corner. If you want to access our full paper, the preprint DOI is right below my email address, and this is what the paper looks like, so keep an eye out for it.